Let's check the difference between Cpk and Ppk and learn how you can combine them, because together they will give you even more information than either of them apart. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video is about Cpk and Ppk. So that's process capability and process performance indices. They are different, which one to use, and also in the end we will get back to how together they will give you an even better picture. But let's start with what is the difference, because they're basically doing the same thing but in a slightly different manner, and knowing what the statistics behind these two numbers do, that will give you a clue on when to use them and what you can usually expect from them. Important to know is that in industry, usually we talk about Cpk the most, and also when we get industry partners, so customers buying our stuff, they usually require a Cpk index, not a Cmk or a Ppk. So a quick rehash: the Cmk is the machine capability, where you take 30, 50 consecutive samples, so really nothing has changed on the machine, same operator, everything, and you just take a large sample and see how well your machine can stay within parameters, so how stable is your machine. The process capability index, the C of capability, P of process, K for this index that you check which side it goes off to. This takes samples from your regular process, and it basically takes samples over changes in your process, but the way you sample and calculate makes that you actually check short-term capability, so short-term stability of your process. The process performance index, so the P of performance, P of process, K of again this index, checking to which side of the limits you are going. This gives you also over your whole process, but taking into account all the data, and therefore estimating how well your entire process, including all changes, operator changes, material changes, are taken into account. So for this, let's check the formulas that get our Ppk and Cpk. Now for Ppk, you have this X bar, which is the average of your samples, and the limit. Now, in the formula, you test for both, right? You test the difference between the average and the upper limit, and the average and the lower limit, and then take the smallest of those. So keep that in mind, but you check for the smallest difference from your average and the limit, and then you divide by 3 times the standard deviation. Now, for the Cpk, you take the same average and also the same checking the closest limit, and then taking the difference between the closest limit and the average, and you divide by 3 times standard deviation. Well, yes, here we take the standard deviation, here we estimate the standard deviation, and that's where the difference is. You see, when we take a sampling plan where each of our samples is actually a number of individual points, we get a range and a sample here. And this range is reflected in the chart under here. You see there is also a couple of points that have almost no spread. So we have a very small range. Now, what the Ppk does is we take all these individual points. So it takes the whole thing into account, and then from that we get a standard deviation that we use in the formula. This range chart can also be used to estimate the standard deviation. See, when we know all of these ranges, we can, with these ranges, estimate the standard deviation. The thing here is, you see the average is going down here, but these individual samples, they actually have pretty low standard deviations. So in this example, what you will see happening is that when you take the standard deviation of all your individual measuring points, these ones have a pretty large deviation from the mean, especially compared to these. So you take all of them together, and this total variation that is in your process gets taken into the standard deviation. Now, when your process is within bounds, so really around your mean, there is not a big difference with taking this range method and getting the same standard deviation. But what this one does is it assumes that the average ranges you get here is the same as the total average standard deviation. And especially when you are going one way, there is a difference between those two. Because from these relatively low ranges, you estimate a relatively low standard deviation. Now, when they are nicely centered, it's basically the same. There is some correction factor in this estimation of the standard deviation to account for this, but in general, what you see, if Ppk and Cpk are the same, it means that your process is behaving nicely. It doesn't mean that it is centered, but at least it is pretty stable. Now, what are the practical consequences of this difference? It means that when we take our Cpk, we are mainly looking at the last number of points that we have, the last samples that we took. So it's a very good indicator for a short-term stability of our process. And this is basically fine. I mean, if you have a nice average and you like it, which is not the case here, but would definitely be the case here, and you know that within this part you have a low standard deviation, you know that the average that you took from your sample is a good indicator for that batch. The previous batches, they might be the same, but they may also have more or less similar standard deviations, but a different mean. What you also see in this example. Now, the Ppk does take all of this into account. What your client demands depends a bit on what they want. It is actually logical that they take the Cpk because you will get them the average of your sampling for that batch, and this has to be within norms, and they want to know that the standard deviation of the sampling is low so that they know that you took a representative sample from that batch that they are receiving. They are not that interested in the total process performance. That's more for your internal quality standards. Some clients will want the Ppk because if they are getting quite a lot of batches from you, they would also like to know that your whole product is nice and stable and that each batch that they're getting is again the same as previous ones. For your internal quality control system, this of course is a very good indicator. In fact, if you have to choose within your company, take the Ppk because that tells you how your whole process is doing and gives you, let's say, the strictest number. So the Ppk takes the most stuff into account, so the most deviation, different machines, maybe even definitely different operators, different materials. The Cpk takes into account basically everything that happens within a run, more or less, and the Cmk really focuses on one machine with one operator, one material batch probably, and the settings are still fixed. So that one is usually the highest, and you use this order also when you're fixing. I made a different video on that one, so I won't go into too much detail right now. But there is a very nice thing that we can draw from this, and that is when we know that the Cpk and the Ppk, basically what they do is, if they are more or less equal, we know that all of these standard deviations or ranges within the sample groups, they are very close together, so they make a nice sampling. That means that when they are equal, Cpk is more or less equal to Ppk, we don't really have any special cause variation. So that's when these two are roughly the same. Another one we haven't really talked about that much, but remember that I mentioned in the beginning that it takes the lowest of the limits. Well, what you will probably know is that there is also this Cp and Cpk, Pp, Ppk. This K coefficient is the difference between just checking how well the spread might fit between your upper and lower limit and checking the average and the closest limit and checking how close we are to that. So the formula for that one would actually be the limits, upper and lower, the difference between them, divided by 6 times the standard deviation. Now, what we know from that is that when the Cp is almost equal or is equal to the Cpk, Pp is equal to the Ppk, we are very well centered. So if Cp and Pp or Cpk, Ppk are the same, we don't have any special cause variation. So the variation we see on a short term is the same as the variation we see on a longer term. When Cp and Cpk or Pp and Ppk, so without and with the K, are the same, we know that our process is centered. So when the Cp is equal to the Ppk, both of these are valid, and we basically have a system that is as stable as it gets with the current variation in your system. So using these indicators together gives you a lot more information about your process. So next to calculating that index that your customer wants from you, make sure that you are calculating the whole set and drawing nice conclusions that can focus where you have to put your improvement efforts. Now that's a lot of information in a relatively short video, so also do let me know if you would like me to zoom in on any of these specific parts. Drop me a comment, ask a question, and I will be happy to get back to any of these specific points. But suffice to say, when you know what the statistics behind CPK, CMK, PPK are doing and how you can also mess with them, but how they will tell you things about your process, you will be much stronger in using these to improve your processes and in the end make more money with your products. Now if you liked it, don't forget to hit that like button, subscribe if you haven't done so already, and for now I wish you the best of luck improving your process capability, but also as always enjoy that improvement journey.